So we're going to hear now from 5 speakers who are going to describe their own successes and challenges from a different set of perspectives. And I'll just introduce the speakers briefly collectively now. So we're going to hear from Natasha Watson at Bureau Happold, Ben Gollum from Price and Myers, and Alison Church from Jackson Church. So a range of perspectives from different practices, different scales of practice, perhaps doing slightly different types of work. So it'll be interesting to hear how their experiences compare. And then we're going to hear from Megan Stringer, who's representing the SE 2050 commitment developed by the Structural Engineering Institute of the American Society of Civil Engineers. So thank you, Megan, for joining us today. It must be pretty early for you right now, I imagine, joining here. So thank you for that. And then finally, we're going to hear from Niamh McCluskey, who is currently the chair of the iStruct's Young Members panel, and she's going to give us some thoughts and perspectives from that panel. So during these presentations, again, please post questions that you have in the chat, and we're going to have some time after the presentations to ask as many of the questions as we can back to the speakers, and we'll do a sort of panel discussion style Q&A. So on that note, Natasha, if I could hand over to you.
Right, so hopefully you can see my screen and you can hear me.
Yep.
Good, sweet. All right, so yes, I'll be giving an insight into Bureau Happold, and we're on the slightly larger scale. And hopefully, there we go. Yes, so apart from being one of the first people to declare a climate emergency because Mike Cook is affiliated with us, we've also set our own targets, and this global sustainability report was released last year, where we want to reduce our own operational carbon emissions by 2025, and we had a target from April this year to offset residual. The key one I think that's applicable to people here is design all new building projects to be net zero carbon in operation by 2030, plus also reduce the embodied carbon intensity for all new buildings and major retrofits and infrastructure by 50% by 2030. Something else that we have been able to do as a larger firm is set up our own embodied carbon calculator and embodied carbon tracker. We've today got 42 projects on there, and because we work on a massive range of different projects, we currently have, as you can see from this slide on the bottom right-hand corner, a massive range of different embodied carbon values per meter squared for modules A1 to A5 for our different projects. Hopefully this will decrease by 2030, but I think I'm confident that it will through upskilling and also through changes along the supply chain as well. But that's a large scale. However, you know, strategy, looking back, looking at what we're doing now is only one part of the conversation. What can you do today to actually reduce the embodied carbon of your project? And this is where I think structural engineers are probably a bit happier because we are doers, really. So as standard for LOD 200 or REBA stage 2, these are the kinds of values that I use when I'm doing sort of quick, like back of napkin calculations for embodied carbon. I use these values for steel, timber, and concrete. I also practice what I preach. So I use the article that I wrote for the iStruct to, you know, just try and keep my designs lean as possible. But then also, whenever we write our basis of design documents, we try and include embodied carbon factors. Using the iStruct guidance, we try and minimize the cement strength of any of our concrete as well. You know, cement replacement is one side of the coin, but the other side of the coin is minimizing the amount of strength that you need in your concrete, because that too reduces cement. But then also, whenever we're talking about things like tonnage saving or material savings, trying to include the carbon savings as well in the same breath, with all with all communication that we have. So this at the bottom here is an excerpt from a colleague's email, and yeah, he asked me what is the sort of equivalent carbon for this tonnage saving, and this really hit home to the architects that we sent this to, that maybe, you know, there was a bit of leeway with this additional steelwork that they wanted added. So that's the end of my presentation. I will now be passing on to Alison, I believe.
Or Ben.
Or Ben, sorry,
either
apologies.
Either way, it doesn't
Yeah.
matter. Whoever's ready to go next.
Hi everyone, I'm Ben from Price & Myers, structural engineer, and I'm just here to talk about some of the work we've been doing in the last couple of years since we signed the declaration. So just very briefly, for those of you who don't know who we are, we're Price & Myers, established about 43 years ago. Medium-sized practice. We've got about 120 structural and civil engineers across our 4 UK studios, and our work covers quite a broad scale, from everything from kind of, you know, hole-in-the-wall domestic refurb up to sort of £200-300 million developments, both new build and refurb. So we cover kind of everything really. And our motto now is that every conversation starts with sustainability. So we're trying to factor into everything that's done across the whole practice. So just in terms of how we started on this journey, so prior to 2019 with the declaration, myself and my team were working on various research aspects with University of Cambridge with Innovate UK funding. So this led to our Panda software, which some of you might have seen, did an article about it in the magazine last year, and it's all over our social media feed and website. So we'd gained quite significant knowledge around the embodied carbon topic, but we didn't really know what to do with it. And it was the declaration coming up that kind of gave us the focus to actually start spreading this knowledge both around the practice and beyond. Fortunately for us, we had very supportive partners, and actually they were keen to not commit to signing the declaration until we could come up with a strategy internally to tell them how we actually wanted to deal with it. We wanted to make sure we could hold ourselves to account, which was very positive. So in terms of what we did, the first thing was basically to start a climate action group. So that's a kind of a group of basically enthusiastic staff members covering partners all the way down to fresh grads. And so between us, we kind of assembled and started to think up a strategy for how we tackle this around the practice. So the first thing we did was to build this simple embodied carbon calculator, very crude, but it enabled us to quickly create a data set. And so we started a kind of friendly competition between the 9 structural teams using what we called the Thunberg Trump scale to rank everyone and get everyone to really commit to producing calculations. So this led to a database of almost 100 projects within 3 months of launching it, which was very good. We did put an article about this, some of you might have seen summer before last, July 2020. And we put this data on our website with the promise of sharing data. And we're proud that the iStruct score system, it helped to sort of calibrate that. So our internal average score is around 340. A1 to A5, which I'll come back to shortly. In terms of how we do our calculations, so basically we've now said that any project with the model, whether that's an analytical model or a drafting model, requires a mandatory carbon calculation. So that covers almost all our projects, apart from the very small ones. Of course, people can do them on more if they wish to. So we've got our own internal carbon calculator. The carbon factors are all centrally set by our climate action group. We've done quite a lot of research kind of based on the ICE data, but above and beyond in many ways as well, using the kind of latest industry research. We also use upper and lower bounds. So we give our data in terms of a range as well as a fixed figure, which we feel kind of highlights the uncertainty still in some of the figures. The main thing is that staff at all levels are being encouraged to upskill themselves. So we've basically got everybody doing these, so partners, technicians, fresh grads, experienced engineers. We're trying to really encourage everyone to have a go at doing it, seeing it as an essential part of our day-to-day jobs. And the focus, rather obviously accuracy is important, but the focus is more on actually getting the calculations done and getting people to understand the impacts of the decisions they're making. We're finding that our engineers are gaining an awful lot from this exercise. So in terms of understanding the material quantities they're dealing with and the relative comparisons between options, it's actually been a great educational curve. So in terms of where we think we're going, So as I said, our average target initially was 340. We were quite ambitious this year. We decided to basically set a reducing target every year to try and get down to this 50% reduction. So our target this year is 300, and we're aiming to get this down to 150 to achieve the scores A, hopefully by 2030, but we'll see how that goes. In terms of our studies of this, we basically estimate that the first sort of half of this saving will be relatively straightforward, and we're starting to see that in our data already. Easy wins such as grids, material spec, etc. And the initial key focus is on raising our staff's knowledge and awareness to be able to deal with this immediately, because this is something we can tackle. Again, I mentioned we have our Panda software, which really helps speed this up and is really sort of proving its worth at the moment. What we anticipate is that the second half, the next 25%, will be dependent on other stakeholders, so the other disciplines, acceptance from clients, planning laws, etc. And this is starting to prove quite tricky on some projects already. And this is where we think things like the Part Z are really key and really urgent, because that's going to push us forward to really make these savings. And then finally, just in terms of how we're sharing, as a practice, we've fully committed to fulfilling our obligations on sharing data and our knowledge. So our carbon database is available from the website. It does need a bit of an update. We'll be doing that at the end of the year, and we will sort of promise to update this annually along with our targets. And what our sort of new exciting development is this climate action page, which you can see on our website. And so we're starting to populate this with lots of little snippets, really kind of thought pieces, bits of data, small option studies, just to try and really emphasize the fact that we are, we're trying to work with the wider industry on this and really try and help everyone to achieve these savings. And we've got a lot more stuff which is due to go up on here over the next few weeks and months. That's it. Thank you, everyone.
Thank you, Ben. That was fantastic. Definitely worth the wait. The Thunberg to Trump scale is that's a new one for me. I love that. Alison, over to you.
Hi, everyone. Hi, I'm Alison Church. I'm a chartered structural engineer in North East England, and nearly everything I do is on domestic projects. I'm a mother and a sole practitioner. I don't have any time to spare, and nor do I have any spectacular carbon saving skills. But I have managed to save a notable amount of carbon over the last year, and hopefully I'm going to share some insights into how I've done that. My approach to saving carbon: use less. Save money and carbon, it's as simple as that. Considering design efficiencies is just engineering. It's what we do every day. It's nothing fancy. And when I've done that, I tend to do a design review at the end with my carbon saving hat on, see if I can shave off a few more kilograms somewhere. Foundations are always a good place to look, as reducing the volume saves excavation and disposal of material, as well as carbon heavy concrete. Loadings, this has been a hot topic of conversation in the Institute's magazine recently, but the overriding conclusion appears to be that the loads we apply allow in the most part for errors in design and on site without leaving our buildings working to their limits. With this in mind, I only design for future loading if I'm specifically asked to do so. Educating my team. By explaining the link between material saving, cost and carbon, I find that most clients are on board. Some will happily pay a little extra for low carbon concrete, others will not, but actually being pleasantly surprised by how many will. Here I've put together a typical project checklist. These are my key items that are within my control as a designer and that really do help to reduce the carbon footprint on my projects. A lot of these carbon savings can also be driven by cost and on-site practicalities, but I have found that taking half an hour to do a carbon count on a project really focuses the attention on small details, marginal gains, if you like. So use less, increase spacings of timber and floors, slim down your concrete slabs, use lower carbon materials like sawn timber rather than engineered timber. Keep the existing, it's an obvious one, but always look to reuse your foundations. And if you can convince your client to restrict the size of new openings, then you don't need a steel frame, it can help massively. And the big one really for me is checking the shrinkability of your clays on site so that your foundations are only as deep as they need to be. Early communication has been vital to getting my clients on board. In my role, the majority of clients have no understanding or past experience of structural engineering. They're often daunted by the massive disruption to their home life and potential economic impact of something going wrong with their most significant asset. These are things that we deal with on all our projects, but really I'm only educating the client with my professional knowledge and communicating it to them in a way that they understand. And this is the same for carbon. In my experience, most clients and on-site teams have little or no understanding about embodied carbon, how it affects them, their projects, and their budget. I've put together some useful information on my website telling clients about what we're doing and why, and this is referred to directly in our fee proposals so that they have the background information from the start. So here's some food for thought. As a small practitioner, we can't save thousands of tons of carbon on a single micro project alone. And alone, we can't commit to halving our carbon emissions by 2050. I've been calculating the embodied carbon on my projects since January. On average, my projects have a carbon footprint of 2.5 tons. That's used carbon footprint, not saved carbon footprint. So that 2.5 tons already includes for the savings that I've made. The good news, though, is that I do lots of projects like this in every year. So if I can save 15% of that average, that's about 1/3 of a ton on each project. And what does 1/3 of a ton of concrete look like? Sorry, what does 1/3 of a ton of carbon look like? 0.8 meters cubed of CEM1 concrete, less than 1 meter cube of concrete. That's like taking 22 mil thickness off a 6x6 slab. And really, I asked myself, is that ambitious enough? Collectively, if 1/3 of a ton of carbon was saved on 25% of all domestic jobs in the UK, it would save 12,500 tons of carbon every year, which is equivalent to 15,000 trips from London to New York. So as a quick summary, even as a micro practitioner, we can all make a difference. Design efficiently, educate your team, and keep a record of your savings. This is what I've been doing. I'd love to hear what you've been doing. Please do get in touch.
Thank you, Alison. Great stuff. Really, really powerful stuff. Progress on every project. Thank you. Megan, if you're ready to share your screen, we'd love to hear from you next.
All right, so thanks for having me today. My name is Megan Stringer. I'm part of the SE 2050 commitment program, I guess, leadership team, and here today to talk to you a little bit specifically about the SE 2050 commitment program, and then specifically one of our requirements, which is the embodied carbon action plan. And sorry, this isn't disappearing, but so to date, I guess the SE 2050 commitment program launched just under a year ago, last November at Greenbuild. And what this is really the US's commitment program to get to net zero embodied carbon by 2050. So as of yesterday, some really exciting program stats. We have just over 750 subscribers to our monthly emails. We just got our 63rd committed firm. We have over 28 ECAPs submitted and just 4 projects submitted to our recently launched database. So a little bit about how our program works is we have 3 main requirements to be a firm committed to the SE 2050 program. It first starts out with needing to get a letter signed by your firm leadership saying that you're going to sign on to the commitment program and meet the requirements. The next part in that is within 6 months of getting that letter committed and sent to us is to create an embodied carbon action plan. And this plan is intended to, outline what your firm is going to be doing in this space. There's some requirements as well as some electives, and we'll get into some of the details there. This plan is publicly made available up on our websites for everyone to read, and it needs to be updated annually. And then the second piece, or I guess the third piece of the requirements, is to then start to report embodied carbon project data to our centralized SE 2050 database that did just launch back in September. And so there's a certain amount of requirements that's going to be required there. And for now, we really wanted to stick with a pretty low bar of entry just to try and appeal to every type of firm with our program. And as time goes on and as we get more data, we'll be able to start to set appropriate benchmarks and then limits as time goes on. So getting into a little bit on the embodied carbon action plan. So we really broke this out into these four categories that you're seeing on screen: education, reduction strategies, reporting, and advocacy. And if we dive into those a bit, so as I mentioned, there are requirements in each of these 4 categories, but also a lot of electives that we give firms options for how they're going to do it. And it's been really exciting to see how many firms are just taking this in different ways. And it's exciting to learn from them and see what everyone's up to. So within education, the main requirement is that you nominate an embodied carbon reduction champion for your firm. And we have heard some feedback that this was something that people really liked, because it was something that they actually had to put some thought into, and it really made their commitment more realistic if they're having to hold people accountable for what they're saying they're going to be doing in this space. Next up was advocacy. So in addition to just promoting embodied carbon, reduction within your own firm, there's also, we really wanted to push that so that you're not only advocating within the industry, but also to the broader AEC community. And then reduction strategies. So providing a narrative about what you've learned about embodied carbon and how you're going to reduce embodied carbon on your projects. Some examples of this is just from Arab, of just an example of how they're going about that. And then reporting. So, we really wanted to have firms start to track their embodied carbon. And I think that that's one of the biggest barriers, at least that my firm has been having, is, we've been doing some very minimal, early on LCAs, but really haven't dug into the depths of it like a similar firm like a Walter P. Moore or a Thornton Tomasetti has already kind of been doing for years. So how are we going to learn from these firms, but also then start to apply that within our own business and what's going to work for us? So we are requiring that a minimum of 2 projects get submitted per office, but we're not requiring more than 5 at this time. Now, obviously, we'd love it if people submitted all of their project embodied carbon data to the database, but again, really trying to keep the barrier of entry to be low so that we can appeal to firms of all size and location. So this is just a sampling of some of the embodied carbon action plans that are up there on the website, and you can go to se2050.org to go see that. If you go under the signatory firm page, all of these are publicly available, and they're really an awesome read. And it's been really interesting to see how creative people have gotten. We did also supply a Google form, which is kind of shown in that bottom left. It's a little hard to see, but so that firms could just fill that out and meet the ECAP requirements that way. But as you can see from just some of these images, a lot of firms have taken it to the next level and really gotten their whole firm engaged in the process and are really excited about celebrating their ECAPs publicly, declaring and sharing that with the broader public, which has been really great to see. And so maybe I just spend another minute just talking a little bit about at least my specific firm's journey. I think one of the biggest and more difficult things was really just to get the firm leadership on board. I think we have a great leadership that's really interested in sustainability and wanting to make a difference, but they're also, looking at it from a strategic standpoint. And, how is this going to make sense for our business? Is there needs to be a business case for this? They really wanted to start out right by asking the right questions. Is this something that our firm is interested in? Is we wanted this to be something that all firm staff gets on board with, that it's not just a select few of us that are really passionate about it, that it's something that we can kind of infuse into our company culture and DNA. We also really wanted to set out a very realistic plan, given that, this is public and we don't want to just say that we're going to do stuff and then not really follow through. So it did take a bit of just thinking about what we put into this plan and then getting the leadership on board and kind of getting them this thing drafted and submitted. And then did I have any other? I think then the other last thing was really just to set, it really forced us to kind of think internally. I think for me personally, like I didn't want it to be just another, jumping on the bandwagon, because right now, embodied carbon has been finally getting its like time in the sun, which has been great, but really wanting to make sure that we're setting meaningful policies and procedures, getting our foundation set up appropriately. And it was really exciting. So we just submitted this last month. And so really excited to really get going on a lot of the things that we're saying that we're going to be doing and start to track our progress as time goes on. And I think because I have like 1 more minute left, I'll just maybe touch really quickly on the kind of third part of the requirements for committing to SC 2050, and that is submitting project to our database. And so it took a long time to get this project database up and running, but it did officially launch back in September, so last month. This is just a screenshot of what that looks like, but what we will start to see is having our firms have access to the database. They'll be able to enter in their project data, and then once we get enough populated, they'll start to see where their projects are sitting within the projects that are submitted to the database. So I think what's populated in there now was a Carbon Leadership Forum benchmark study from 2017, just so that we have something in there as a benchmark, but obviously we'll be developing those hopefully within the next year for the data that we're seeing getting submitted. So I think that is all that I have, so thank you.
Thank you, Megan. That's fantastic, and really great to see how wholeheartedly the firms that have signed up have kind of pulled together their ECAPs and how comprehensive that is. And also, I thought you mentioned that was interesting was around business case as well, and we haven't touched on that yet, but maybe that'll come out in some of the Q&A in a bit. So thank you. And our final speaker, if I can hand over to Niamh.
Hiya. So thank you for giving me the opportunity to speak today on behalf of the young engineers across the structural engineering industry. So a bit about myself. I am the current chair of the iStructE Young Members Panel, and I'm also a member of the Climate Emergency Task Group at the iStructE. I currently work as a project engineer at Curtains, and the main reason why I joined the iStructE Young Members Panel was to be part of the young voices who drive decisions and direct change in our institution to connect other like-minded engineers and promote diversity in the institute. So in July 2021, we hosted a virtual Young Engineers Conference focusing on mental health and the climate emergency with the role of a structural engineer. This past year has been about getting through the COVID-19 pandemic, taking each day as it comes. And for most of us, the main consistency was our work and our job. This is why it was so important to myself and the team of the young engineers to look at something a little bit different this year for the technical conference. The industry had paused and stopped looking forward to the future, and we wanted to spark that action again and the conversation on the effect of well-being and the effect our industry has on the planet. So why is the feedback from this session so important? Who did we reach? The conference reached out to over 200 young engineers at many different stages of their career and extended out to 38 different countries. The climate emergency was a popular topic for the attendees, with over 35% attending due to programme content, and 45% of the attendees choosing the climate emergency topic as their highlight from the conference. 64% of the attendees weren't currently in a managerial role, but put themselves as a future ambition within a business. So the comments, statistics and figures that we got from this conference not only reflect current engineers, but they also reflect the people who could be our leaders in the future. So what did we ask the engineers? So we asked them a series of anonymous questions. We asked, how do you feel about what your firm is doing and around the climate emergency? What do you want more of? What do you want less of? And do you have any other thoughts? We gathered this feedback via an anonymous Miro board, and to briefly touch on some of the points that stood out to me. In best practice, some firms are selecting clients based on design outcomes, and directors are ensuring that projects have good social and environmental impact. Firms are also setting up focus groups on sustainability and carbon calculators and hosting seminars. However, the feedback also highlighted some key areas for development. Particularly, the feedback showed an inconsistency across firms and projects and within businesses and within the industry, looking for best practice and data to be openly shared. It is also clear that although firms are starting to touch upon embodied carbon in the design stages, it remains not a key design decision maker or a driver or a priority to many clients or design teams. So how does this reflect back to the structural engineers declare you and your business? By signing the Structural Engineers Declare, you committed to strengthen your working practices to create structural engineering outcomes that have a more positive impact on the world around us. Briefly comparing some of the Young Engineers Conference feedback to the commitment signed shows not only the alignment of the structural engineer commitments and the young engineers' expectations of the industry, but it can also be used by yourselves to reflect on what signing the agreement meant to you and any changes that you may have implemented since signing. So reviewing the feedback, I took 3 of the key Structural Engineers Declare commitments and compared them directly to what the young engineers had commented back. So firstly, to collaborate with clients, architects, engineers and contractors to further reduce construction waste. Coming from the feedback, young engineers are looking for their companies to lead sharing data across the industry on the embodied carbon and best practice of their projects, to collaborate with design teams on waste and carbon reduction. Secondly, the commitment to adopt a more regenerative design principles in practice with the aim of providing structural engineering design that achieves the standard of net zero carbon. The young engineers wanted to be given support, encouragement, and the confidence and time to learn about our role in the climate emergency and net zero carbon, and for it not to be seen as too much additional work, and with knowledge sharing and embodied carbon seen as a key design driver within their companies. And finally, to evaluate all new projects against the aspiration to contribute positively to mitigating climate breakdown and encourage our clients to adopt this approach. From discussions at the Young Engineers Conference, it was clear that they were finding that the embodied carbon in a project is often seen as a tick box or a greenwashing exercise, and very little changes are actually reflected in any design based on these calculations. They see a gap in the resources and knowledge from the institution that's been shared, and then actual construction practice in the industry. And they are looking for firms to support the institution in creating policies and help create a culture to bridge this gap, using the connections and influence that you all have. So in conclusion, I'd like you to use this opportunity to reflect on the feedback and think about the things you can share which have been a success story or lessons learned within your business, or how you can commit to the younger generation in your workplace to support changes and ensure actions actually come from the signed commitments you made. So thank you for listening. If you've got any questions, I'll try and answer them as best I can.
Thank you, Neve, and thank you to the Young Engineers group. Lots of food for thought there, I think, for many of us and for many practices. So that's great. So we've got about half an hour now to have a little bit of Q&A and to ask some questions of our presenters. There's quite a lot of questions in the chat. I'm going to scroll back up to somewhere near the top, and I see a question from Mike Sefton there, a question to Natasha about how Bureau Happold have established their baseline for the embodied target reduction by 2030. Natasha, perhaps you might
sure.
have a go at that.
So we did actually toy with the idea of having a look at whether we should sort of look back 2 years, figure out what we'd been doing, and then try and achieve 50% of that. But then we kind of decided against it, mainly because of the alignment of the LETI targets and the scores targets, etc. That we didn't think that was ambitious enough. So we took the baselines that had been agreed by sort of LETI scores, etc., and then halved that, and that's our target. So we thought, yes, we could look backwards, but that's not ambitious enough. So that's how we set our sort of baseline. It's a fictional baseline, as you saw from our massive range of projects that we had there, but we kind of decided that we wanted to go more ambitious. So that's how we decided that, Mike.
Great, thank you, Natasha.
No problem.
There's also a question just below that from Arthur around the unified carbon factor for GGBS, and Arthur's gone full out on the acronyms here. Whether we have ECF's embodied carbon factors changing for electric arc furnace steel and its reliance on fossil fuel byproducts.
Yep. So I think that there is massive change happening within the supply chain. And I think rather than necessarily there being a unified embodied carbon factor, there will be updated embodied carbon factors year on year as everyone is moving towards lower carbon strategies, practices, work, etc. So I don't necessarily see it being a unified factor and then it doesn't change. I see it as year on year, we update our knowledge, we update the embodied carbon factors because we're all making progress. So that's how I see it working, but I'm happy to be challenged on that. I'm happy for other people to feed in.
Does anyone else have any views on that? See it playing out slightly differently, or are we in broad agreement with Natasha?
in Will, if Will's there, in his comments, because he's so deeply into this.
Yeah, I was trying to find the unmute button. The thing I'd say on the concrete side is there is a group called the Low Carbon Concrete Group, which sits under the Green Construction Board, and the iStruct sort of representative on that is Paul Assel, who's sort of quite deep into conversations around cement and concrete in general. I don't know if Paul's with us today and wants to sort of add anything else in beyond what I say, so do shout up if you do, Paul, and you are here. But there's that group is looking at sort of trying to plot out what a sort of trajectory looks like for low carbon concrete versus normal carbon concrete, if that makes sense. So yeah, we've published a few articles over the last year about things like GGBS. We talked about steel as well. On steel, there's Responsible Steel, which was set up during this year. And if you go to responsiblesteel.com, you can find out a lot more about what they're doing about carbon factors. And now cement and concrete is the sort of like missing gap alongside it. So what the low carbon concrete group's looking at is trying to set what the baseline is for different strengths of concrete, so that you're not accounting for how much cement replacement you use, you're accounting for sort of the ways concrete is produced, stuff like that in the first place. I don't know if that's really answered the question, but I guess in a nutshell, there's development happening around this, and I agree with Natasha that things will be continually updated over the next few years on this topic.
Thanks, Will. And in terms of the carbon factors that the iStruct's published that sit in the guide, how do you see that as being a live document to kind of evolve as the industry evolves in this way?
Yeah, so yeah, okay, so actually two more comments then. So on the guide itself is currently being refreshed. I feel like I've been saying that all year, but we truly are nearing the end of that tunnel now, and hope to release sort of version 1.1 of the guide at least this side of Christmas, if not sooner. That has an updated table 2.3 inside of it. To my memory, the carbon factors around concrete have not really changed in that. Steel factors for the UK have changed fairly significantly since last year because of some work that's been done by the SCI and the BCSA, which is the British Constructional Steelwork Association, looking at sort of UK consumption factors for steel, whereas previously we only had production factors in there. And timber factors are getting sort of scrutinised at the moment as well. So that I'd say that yes, that table is always going to be a live document, because as an industry we're going to continually be updating our knowledge on this topic. The RICS database, also the Built Environment Carbon database that I mentioned earlier, this is my second point. When that goes live, that will include a carbon database part of the site. And the idea of that is that that will be truly live because it's live on a website and it feeds in EPDs from all across the industry and things like that. So the hope is that once that is up and running and is populated with enough data, that will become the go-to place for this content, so that when things are updated, you don't have to wait for us to update a PDF copy of a guide, which obviously takes time and effort. So hopefully in the future, we'll see these things happen a bit more slickly than they do at the moment.
Perfect.
Do you want me
Thanks,
to
Will.
come in, Will? Sorry.
Oh, hi, Paul.
Sorry, I couldn't unmute myself, but I can now if you want me to just add a few words.
Yeah.
So as Will said, the LCCG are working on a route map to help inform everyone, which will be published. I'm not going to say when, but let's say soon. And something to be aware of with concrete is that as we move forwards, obviously GGBS does not have a long-term solution because it's going to run out, and also we can't use it all the time for all concretes. So what we're going to see is a much greater range of blended cements, hopefully using things like calcined clay and or other materials that may be available. So what the future might be here is that as structural engineers, we'll be specifying our concrete with an embodied carbon and working with our suppliers who will give us a concrete which may have one of many blends to achieve that embodied carbon. So I think for now it's really important that we do have an understanding of these numbers, but they are going to change and new blends will come with different factors. And I don't think it's reasonable to expect engineers to know them all. But the point is that we're going to work with suppliers to get the lowest carbon concretes that we can for a given project.
Thanks, Paul. I just noticing there's a question slightly further down the chat on a similar topic around, do we produce enough steel to sustain demand for GGBS domestically? And if we have to import from elsewhere, do we include that in our carbon calcs? It gets quite complicated, doesn't it? It can do. But I think your approach kind of helps respond to that complexity. Okay, moving a little bit further back up. Another one for Natasha around, again, using lower concrete grades, but whether the carbon saving there balances out with the increase in rebar requirements. Natasha, specific one there for you.
Yeah, so a little while ago, my colleague Jonathan Roynan released sensitivity studies, which are also available on the iStructy website. And from that, we found that typically for superstructure uses, C3240 was kind of a sweet spot for thickness of elements and reinforcement requirements. So it obviously depends on what you're doing and what's governing, but we found that C3240 is a very good starting point, and then see what your limitations are, see how that comes into play, and then if you can have a low strength concrete, try and go for that. But obviously, yes, balance that with your reinforcement quantities as well. You might need to do a bit of a more localized sensitivity study, but start with C3240. I think it's a good place to be.
Brilliant, thanks, Natasha. Does anybody else have any comments on that one? Sounds like a sensible approach.
Only to say that, I mean, typically in reinforced concrete, I mean, the rebar will be something like 20% of the carbon emissions of reinforced concrete will be due to the rebar, whereas the cement by itself is about another 60% or so. So if you imagine you have to add quite a lot of rebar to make up for a small reduction in cement content to get things to balance out. So I'd go with this sort of gut feel that probably weaker concretes with a little bit more rebar are probably going to work out lower carbon overall. But of course, do the numbers, as Natasha says, just do the study. It's quite quick to do.
Brilliant, thanks, Will. A couple of comments in here, not so much questions, but comments around around Alison's presentation, and bringing home the saving to be made by taking 25 mil off the thickness of a concrete slab. It's quite a sobering point. Thank you, Alison, for that, and also the really important point that David Leversha makes about raising awareness with the general public through. There's a lot of this in the news even today, isn't there, about swapping out domestic boilers for heat pumps and so on, and raising the awareness around embodied carbon as well as operational carbon with domestic clients is a really important point. Thank you, David, for that comment. Another comment here from Mike Gruniak, 60 projects on the database. I presume that's the SE20 database, SE2050 database. So that's fantastic. Obviously taking off there. I'm going to move down to a further question from Nina around reuse and adaptability, flexibility versus utilization. So this looks like a good one about future-proofing buildings for additional stories and so on. So I don't know whether there's a specific question in here, but just around, where should we be aiming at, I guess, in terms of designing for future reuse and adaptability versus minimum embodied carbon. I wonder if any of our speakers would like to have a go at giving a view on that important question.
I know, I'm probably sick of my voice now, but I would say that designing for tight fit functionalism now is better than designing for a possible change of use in the future. My belief is that we need to reduce our carbon emissions now. Carbon emissions emitted now are more important than possible ones in the future. Also, in the future, we may well have much lower carbon construction techniques, materials, etc. And yeah, I think that adding the additional weight in or adding the additional material that you need for those future use loadings definitely into floor plates, it doesn't really balance up. You can put it into your columns and then strengthen your floor plates later, either using carbon fiber or other methods. There might be other ones in the future, and that actually balances out to being a lower carbon option in comparison to adding the additional material to your floors today. So that's my 2 cents on it.
Can I build on that? Which because I agree with what Natasha's is saying completely. There's a couple of things I always point out to people. One is that certainly in this country we're saying that we're going to be net zero by 2050, which means that any strengthening works you need to do to a building 2050 or afterwards theoretically is going to be sort of zero carbon, or at least very low carbon compared to today. So there's a bit of a question in that if in 28 years time I have to edit this building, is that worth me making allowances for today? The other thing I'd point out is try and think of today's carbon emissions as a sort of investment, where you would only choose to pick something other than the lowest carbon option today if there's going to be a substantial return on that investment later on. So if you think that you've got an option B, which is 5% higher carbon than option A, but it's going to give you significantly more flexibility further down the line, or maybe instead of flexibility you're looking at resilience or demountability, or there's a significant amount more carbon sequestered within it, and that only requires a small extra investment now, maybe you'd make an engineering judgment call that option B is worth going for. But if you're talking about, well, we should just put all the columns twice as far apart because it's going to be more flexible, or we should add a load more strength today because it will give more possible adaptability in the future. Making those decisions today without really knowing what's going to happen further down the line is kind of like gambling. So think of it as an investment, ask yourself whether it's worth it, and then make a bit of an engineering judgment call on it, is what I'd say.
That's a well thought through strategy, Will. I wonder if Ben Gollum is still on the line. I'd be quite interested to hear what Price and Myers' view on this, only because you do such a range of different projects, including a lot of adaptation of existing buildings as well as new builds. Whether you would have a similar or perhaps slightly different perspective on this, Ben, if you're still on the line.
Hi, yeah, sorry, still here. I was just actually on the phone, so I'm afraid I missed the question, but I'll happily answer if you can.
Yes, I won't make you guess the question. So the question is about thoughts on reuse, adaptability, flexibility versus utilization. So in other words, should we be designing to allow for future flexibility, extension, adaptation, or for minimizing carbon now? And I was thinking as a practice that probably sees both ends of that telescope, the frustrations of not being able to do what you'd like to do with some existing buildings, plus also the challenges of designing new buildings, whether you'd have a different perspective on that to others.
Yeah, definitely. We're trying to focus on minimizing carbon. I think that is by far the priority. But we are using the tools we've got to make sure everyone can try and do an assessment as much as possible and actually look at the trade-offs. And so one of the points I did note was picked up. One of the things we're trying to push is to push the other disciplines as well, particularly MEP, when we're talking about long-term trade-offs of things such as operational carbon against embodied carbon, and trying to quantify the actual difference between the difference between them as we look at different options, and that kind of comes down to flexibility as well, in terms of services. But generally speaking, it's this point that I think, as Natasha alluded to, the carbon is being emitted now, so there's no point trying to gamble and say, well, we'll just emit a lot more now and hope we can kind of save it back later. I think we're looking at the decarbonising of the grid, especially, is one where we think actually a lot of the figures looking at for operational carbon might not be realistic further down the line of the building's lifetime. So the focus should be on this A1 to A5 and nothing else, as far as I'm concerned anyway. And that's what we're trying to kind of instill within our engineers. Does that answer the right question?
It does, Ben. It's great. Thank you. I noticed that Mike Cook has got his hand up here. Mike, do you want to add something on this?
Just quickly then. When we talk about, we as structural engineers might well want to avoid over design and future flexibility. It's slightly countercultural to what we've been trained, but we must remember that our clients are being advised potentially by their lenders that they want to add value, they need to have this flexibility. So we've got to be mindful of the fact that we're likely to be speaking contrary to what the money says. And that's why it's so important that we kind of take the client with us on this carbon thing, and kind of look after them from the very beginning of the project to get them recognizing this counter argument, if you like, to what traditional money says. And I just wanted to raise that because we've got to remember that we're not working alone. I mean, these buildings get built because people have money and want to put money into the building. So we have to be mindful of what they think and how we can persuade them that they need to think a different way. That's a longer story, but I wanted to get that on the table.
Thanks, Mike. That's a really good point. And yeah, I mean, I suppose my own perspective on this one is I think I agree with both Natasha and Will's commentary, really, and it's about getting, for me at least, getting the sort of biggest bang for your buck. And if your vertical structure and foundations is 15% of your carbon in your building or thereabouts, to add a little bit more resilience there as the two bits of the building most difficult to augment later, but making your floors as lean as they can be because they are easier to strengthen later. It's that sort of strategy that perhaps is it's a blend, isn't it, of that return on investment. Okay, that's great. I noticed, Mike, you had another question here to Megan around the funding of SE 2050 and how it's
well, Megan did answer it.
Oh, did she? Okay.
Anyone could read. You could read that. I think that they're in discussions around sponsorship and would like some more money, please. Because I mean, I salute them for having got so far, but I do know that in the end, money counts, and to be able to organise something like that does require people to spend time. But good luck, and get some good sponsorship. America has a good way of doing that.
Thanks, Mike. Yeah, we're trying to look at, we'd love to get some full-time staff, et cetera.
Yeah.
So it's just going to be limited by that, by the amount of funding we get to see how far we can really take it.
Yeah. Good luck.
Okay, great. Thank you for that. I haven't been scrolling that far down now, so I haven't got any more questions lined up here. Mike Sefton, I think maybe Mike perhaps you've been having a look at some of the other questions, whether you'd have spotted some good ones in there as well.
I did. There's one earlier on that I don't know whether you jumped over, but it was interesting. We're talking about whether we have fixed embodied carbon factors across the industry. There's one maybe to Ben, and I was wondering whether that links into their upper and lower bound estimates that they were using, because they don't feel it's a fixed figure across which we might be comparing across the industry at the minute.
Yeah, so what we've basically done is because we've been working a lot with Cambridge, who do a lot of work on the embodied carbon stuff as well. The particular example, I guess, would be concrete, whereby we've done a lot of studies of actual real concrete mixes, and we've sort of worked out what we're actually getting in the mixes, that as opposed to what we're specifying. And so the way our tool works is it kind of reports the main value, which aligns with the ICE database, iStructE guidance. But then we've looked at what the concrete suppliers are actually giving us. We kind of recorded several hundred mixes and and looked at what they were putting in, and that gave us a sort of range. And so we've spread it based on that, and we've used that kind of principle, for example, where we have different EPDs for different products, which are all kind of in the same, such as composite decking or CLT, for example. And so it's to kind of to give the engineers a spread of values, but focusing on the average one to kind of help sort of early stage decision making, if that makes sense. So there was quite a lot of work involved with it, but it was quite a useful exercise. And the range is quite substantial for certain types of building. But obviously, as the project kind of refines down the design stages, we kind of can shrink that range slightly. And as specific products are actually used, then we can obviously eliminate a lot of the uncertainty and use that specific value.
Super, thank you. I think there's a sort of almost a follow-on from that or similar question from Andy Yates asking, when do speakers think we should aim to have the same calculation methodology, targets and reporting requirements in use across our profession, or is this an unrealistic aspiration? Although, having opened that question out, I think that's maybe the big question we're asking through the whole of today's session.
I think if any of our presenters want to have a go at that one, then that hairy one, then they're welcome to. But happy to leave that as food for thought for later discussions equally.
Okay, I'll take that one. There's a question by Alan as well. I don't know who to address this to, but it was talking about they've had lots of discussions on current code live loading being generally too conservative compared to what load we actually get on buildings, and asking, has there been any progress on revision of current codes? It's another tool that we could use to significantly reduce embodied carbon in our buildings. So does anyone have any updates or thoughts on that?
This came up at the targets thing last week as well, actually. The first thing I'd say is that there was a short paper published earlier this year on the topic of code loading, which kind of highlighted, actually, I think to me the main takeaway message was not that the savings through being able to sort of skim down the loadings a bit further are huge, but it did highlight the fact that there were many people still over designing beyond those loadings. So the key message of that being design for that load and no more, as one particular engineer would always say. The conversation that was had at the targets roundtable that we held was that there is some wider flexibility within some of the EU codes already, but the problem is that trying to utilize that in your designs is fraught with, people don't really know how to go about doing it. There's not good design guidance out there that you can sort of use to back up any assumptions you make and stuff like that at the moment. So off the back of that, we're going to try and sort of instigate a bit of a discussion with some of the people we know who are involved in the EU codes to see if we can generate some of that guidance about how you go about using that bit of flexibility the EU codes does offer, in order to make more sort of efficient judgment calls on your projects. And we're also going to have a discussion about whether there are things within the UK National Annex that could be updated a bit quicker than simply waiting for the next generation of Eurocodes, which is at least not going to come till the latter half of this decade. Yeah, that's my input on that.
Thanks, Will. Does anyone else want to share any thoughts or comments on that point about over design? One other point I picked up through that same conversation that Will was alluding to was around code requirements in general. So loading is one, but then obviously serviceability requirements are another. And a point that was made, again, of course, if you get your spans and grids as efficient as they can be, then you're typically designing for strength rather than serviceability, and obviously a tighter grid and reduced span has more of an effect on carbon than the loading as well. So in a way, there was quite a strong theme coming out of that conversation was, if we just design efficiently, then we don't have to worry so much about some of those serviceability criteria, and we'll save more carbon than we will do by just shaving off the loads in any case. But yes, I agree, we should push on all of these fronts, shouldn't we? Mike, do you have any more questions that you spotted just in the last 5 minutes here?
Yeah, there's one I like Stephen Smalley asked. In people's view, is there as much investment into new technologies, techniques and innovations into testing and verifying existing structures and the ways to extend life as there are into new material innovation. So are we pushing as much into the reuse side of things and making that as easy as possible and as good as possible? I'm not sure who we would address that to best.
I would actually be interested in Megan's view on this, whether this reuse first policy and a sort of growing emphasis around investing in building reuse is something that's also prevalent in the US.
Yeah, well, I mean, it's always that adage of the most sustainable building is the one already built. I think is something that should get more play than it actually does. I've been having some interesting conversations lately more around like digital twins and how that could kind of play into this whole topic of reuse. And if we as an engineer knew better like the actual how buildings were constructed and what was actually in there, if we had a better model of that, we'd be better able to adapt certain buildings for reuse. But yeah, it's an interesting topic and one that I think hasn't yet gotten as much, I don't know, play as it should be as a strategy for that. There are some engineers over here that are really focused on existing buildings and really preaching that, you know, that's how we're going to get out of this problem, is really focusing on them and reusing them and reusing the building stock and really pushing for that. But it still isn't yet, I feel like, the most prominent strategy that gets looked at here, but definitely something that we should be looking into more. And if it is looking into, you know, there's been lots of talks about adaptability and, you know, designing for future uses. And does that mean we put a blanket like 100 PSF live load on our structures, or do we, to allow for that? I think we as an industry could do a better job at addressing that and looking at some actual realistic ways that we can move forward.
Thank you. Thanks, Megan. Mike, you've got a hand raised again. Did you have a comment?
I just wanted to add, I thought it was a great question. I'm very glad it was asked. And I just deposited something there about, you know, we need to be thinking so much more about how we avoid the new build and embrace the reuse. And I think technology, digital twins, as Megan was saying, is such an important thing. We've got these capabilities now, not to be scared of existing buildings, but to go in there and understand them to death. And it's got to be made worth it to make that sort of investment, but we need to do it. And it reminded me, I think Will remember, I hope I've got this right, but I think Rosella Nicolin at Lang O'Rourke's talked about they were getting very interested in that aspect and getting more into the potential for we engineers and contractors to understand existing buildings and what they can do with them better. And so there's a fantastic untapped potential there for the future, which is an absolute necessity for rapidly decarbonizing. So it's a good question. And we do need a lot more investment into that. It's not glamorous enough at the moment, but if you go heavy digital and digital twinning, perhaps it can get glamorous.
Thanks, Mike. We've probably got time for maybe one more question before we pull this to a close. Alison, you have your hand up, please. Or you did.
Yeah, I'll come to it later. Don't worry.
No, are you sure? Okay, all right. Then I'm gonna just pick one last question. I'm sorry, there's loads of great questions and comments in the chat. Thank you all for your contributions there. But in the interest of time, I'm just going to pick one to end this session on, which I was struck by Dan Green's question about, has anyone tried to break down where they think the carbon savings will come from? For example, 20% from efficiency savings, 20% from building differently or nothing, 10% from decarbonising existing materials. I think that's a really great question, and I know that that during the presentations there was a sort of a view that the first 25% of savings was going to be easy, but the next 25% was going to be much harder. But I don't know if anybody's actually tried to sort of map out where we think those savings will come from to get from 350 down to 150 or whatever the ambition might be. Would anybody like to have a go at that?
Yeah, I'd referenced the UK GBC's whole life carbon roadmap that was released for consultation a couple of months ago. The consultation is closed, but the document's still online. If you Google it, I'll stick a link in the chat. In that, there was one working group looking at design efficiencies and looking at, what studies out there show how much sort of design efficiency could realistically be achieved over the next 28 years. There was separate groups looking at what different material supply industries are looking at in terms of decarbonisation of their own products, and then it sort of pulls it all together to sort of show where the industry is going. So from memory on that, the sort of figure that was settled on around likely increased design efficiency, allowing for the fact that you're always going to have trimmers around stair openings and things like that, which means you're probably realistically never going to trim all of this spare capacity out of, was something in the realms of like 20% or something, which again in the same sort of ballpark as the figure that was mentioned before, in that maybe shaving off the first quarter is within our control as a design team, but the next quarter needs you to go a bit wider than that. And that kind of aligns with the thinking that I've had to over the last year or so, is that if you've got the right client who's really pushing on this to save 50% over business as usual, I think it's feasible at the moment, and there's the odd case study out there, but you really do need that to be backed by everybody from client onwards, and if the client's then going to be renting the space out to others, also people who they're likely to rent it to would also need to be behind this. So yeah, I kind of agree with the 25-50% split that was shown before.
Thanks, Will. Anybody else want any last comments on that question? If Megan.
I was just to say, we had a slightly different take, at least in the US, that I think Mark Webster just put in the chat, and I put in the chat earlier, of looking at how you can actually get to zero and where we think how we think that's actually going to play out. And we had 4 different areas of where we thought we could get there, and explore different tracks of how you could get to net zero, looking at a different combination of kind of those 4 strategies. And so anyway, there is a link there if you guys are curious to take a read through.
Perfect, that's great. Thank you, Megan. So look, we are at 4 o'clock, so I'm gonna draw this session to a close. I'm sorry we didn't get to everybody's questions, but loads of really great stuff, and knowledge sharing and information sharing in the chat as well. So thank you all for that. So we're going to take a 15-minute break now. If I can ask for everyone to be back online at about 4:15, and we'll start the final session where we'll be asking ourselves, what more can we do? How can we raise our collective ambition going forward? So please come back in 15 minutes armed with your thoughts around that. We'll start by sharing a little bit more kind of food for thought, and then we'll be moving into breakout rooms to work that through in more detail. So see you all in 15 minutes.